Hello and good day to you. You're once again welcome to MS Constructions, where we discuss all things engineering, architecture, and 3D modeling. Today, we'll be learning in AutoCAD how to prepare your 2D architectural plan for Blender 3D architectural modeling. And we'll also be learning in Blender how to convert a 2D architectural plan plotted in AutoCAD into a workable 3D architectural model. But before further ado, we encourage you to subscribe to our channel for more tutorial videos like this on AutoCAD for architecture and Blender for architecture and 3D modeling. And don't forget to turn on your notification bell to be the first to see our latest tutorial videos on these topics. Thank you. Now, let's get right into the video tutorial. This is my AutoCAD workspace and I have this architectural plan right here. I'm going to choose one of them and then we can go on to create a 3D model for the 2D architectural plan using the Blender software. Now, before we proceed, we need to set up the 2D architectural plan, and this means getting rid of the layers that we don't need. For example, we don't need the dimensions, the doors, the windows, and pretty much anything other than the walls aren't needed in our plot. And the reason for this is because we need the plots to be as simple as possible to make it workable in Blender. Now we are left with this arc here. We don't need it, but I can't turn off its layers because it's on the same layer as my walls. Hence, the other option I have is to hide it. So I can simply select it and type hide in my command center and click on hide objects. We have our 2D architectural plan set up with just our interior and exterior walls left. And this is all we need to create our 3D model in Blender. Next step is to plot our 2D architectural plan. And we can achieve this by going to our layout interface. However, we will be plotting our 2D plan as an image and not as a PDF this time. We can adjust the focus of the plot to the selected 2D plan as shown, but in case you don't know how to plot your project in AutoCAD, we have a tutorial video on that, and the link to that tutorial is provided in the description. You may kindly check it out. Now, in order to plot this, we can use our zoom and pan tools to center the plot and move it away from the other plans as shown. We can exit this and move our cursor to the layout panel. Let's click on layout and select plot. I'm going to leave my settings down here exactly the way it is, and perhaps you can do the same too. As our focus is to plot the plan as an image, we can go on to select publish to web PNG transparent, as this offers a better result and gives us the plot exactly the way it is set up. You could also choose publish to web PNG, but you will have to adjust the orientation of the plan in Blender, which may not be such a big deal, but I guess it's a matter of preference and what works for you best. I kind of prefer this and also want my image to be transparent and easier to work with. Now, once you select this notification pops up and it says the plotter configuration does not support the paper size of the current layout. And considering that, I think it's okay for us to go with the first option. Here we can choose any paper size, but I'm going to just settle for the default paper size, and then we can go on to see the plot preview. This is what we have in our plot preview and it looks okay, and I think we can work with it. Hence, we can close the preview and plot. We can simply press OK to plot. However, you may adjust plot options based on your preferences. Nevertheless, I'm leaving them the way they are and can go on to press OK to plot my 2D plan. We can rename the plot as shown. We can rename this AutoCAD to Blender 3D. And once you press save, it plots automatically and pops up with a notification of the results almost instantly. You may go and locate the plot and check it out just to be sure. The file path for my plots are in my documents. However, my quick access tab provides a faster approach to accessing my AutoCAD plots. This is the plot and I think it's good enough for me. It looks a little blurry, but I can zoom in to get clearer details. All we need is something nice to work with, and we have that. I think we can proceed from here. I can close this and go back to my AutoCAD workspace. We can now exit the AutoCAD workspace and go into our Blender 3D interface to import the architectural 2D plan. We can delete our default cube, then press Shift A to add an object to the scene. However, this time we will go to Image and select Reference to add our 2D plan. Now we need the file path to locate the architectural 2D plan. I have it in my documents and for me it's easy to find, so I can simply scroll down with my middle mouse button, but for you may need to use the search bar. Okay, there it is. Double click on the file or simply select it and go down to select Add Empty. Here we have it. However, the orientation seems to be off. We need the location and rotation to be centered, and in order to do that, we can reset the location and rotation by using the shortcut Alt G and Alt R. Nevertheless, I think it's just the rotation that's off, and we can simply use Alt R to fix that. Before we continue, I would like to go and enable my screencast keys in order for you to see the procedures of my workflow, and you can see a replica of my mouse right here. That's what the screencast keys does. Next step is to convert our object into a grease pencil curve. Better still, from the options as shown, trace image to grease pencil. You can leave new object as target object. You may decide to adjust the radius of your object, but I'm leaving it as default for now. For this tutorial, let's go with the default. So we can simply press OK. You'll notice that it traced out the layout of the 2D plan from the empty plane, and we have it as a different object right here, while the empty remains intact. We have both objects in our scene, but our focus is the 2D architectural plan. Hence, we can delete the empty plane, and what we have now is the transparent layout of the 2D architectural plan. We can go to edit mode to visualize what our layout looks like. It's shown. You can edit vertices, however I would advise leave them as default for now. Press A to select the object and go to your grease pencil settings as shown. Find stroke definition and change 2D layers to 3D location. Once you've changed it, in object mode you notice that your object now has some thickness added to it. However, we are not there yet. Select the plan as shown, go to Object, navigate to the bottom as shown, select Convert and convert the grease pencil to a mesh. Right here, we have an editable 2D architectural plan and we can comfortably work on it to develop a 3D model. You can see that the vertices are now editable with the vertex select mode option on and the edges in edge select mode as well. We can rename the object from grease pencil to house plan. And while this looks good, there are still some minor adjustments that must be made before we can develop this into a 3D model. If you recall, AutoCAD doesn't afford the opportunity to design to precision with units other than the imperial system, and this 2D plan being drawn using the metric system had to be assigned AutoCAD units, which doesn't precisely correspond with the units of the metric system. Hence, we need to adjust the values of our AutoCAD units to the precision of the metric system in order to model a 3D architectural plan that is relatable and drawn to scale. We will be using the millimeters as our unit of measurement. Now, to better understand what we are trying to do, we can go on to enable our edge length as shown and then try to get the dimension of any part of the plan. And you get to realize that what we have for the dimensions of, say, the pillars are unrealistic for a practicable architectural drawing, and this is a flaw on the integrity of our 3D representation. For example, this edge gives us 116 millimeters, whereas going into the architectural plan on AutoCAD, we have it to be a 450 mm wide column. And this is as a result of the discrepancies between the values of AutoCAD units assigned to the drawing and the metric system. Before we work on the plan to adjust the scale, we need to work on the geometry of the plan, and as you can see, there are too many vertices here, and we don't need this much to get a foundational mesh for the development of our 3D model. So we need to dissolve some of these vertices. However, we have our edges doubled and need to get rid of that first, as we need only a single edge within our object to model our block walls. Therefore, select inner edges as shown and delete them. For clarity and to reduce the workload on my operating system, I can disable the visibility of my edge lengths. Now with all the inner edges selected, we can go on to press X and select the edges option as shown. Then we can toggle back to our vertex select mode. All we have, as you can see, is the outer boundary of the plan, and that's all we need. We can now proceed to select the vertices that aren't needed to maintain the geometry of the 2D architectural plan. Here now, we have a simple 2D plan and a perfect replica of the 2D layout from our AutoCAD project. The next step is to rescale the dimensions of the 2D plan to fit into the metric units that we have in Blender. And in order to do that, we can go back to enable our edge length. Then we can use the discrepancy of the dimension of this wall on Blender and in AutoCAD to evaluate the factor of the discrepancy. The value of this 116 mm wall in Blender, which in AutoCAD measured 450, can therefore be used to compute the scaling factor that will produce a 450 mm equivalent on our Blender workspace. This factor is basically obtainable by simple proportion. And then we can go on to select the entire plan and scale it on X and Y axis by this factor. Let's get on with it. Now, if 116 mm equals 450 AutoCAD units, then one Blender unit equals 450 divided by 106, and this gives us approximately 3.87931,035. We can simply make this approximately 3.9 and then return to Blender to scale our 2D plan by 3.9 along the X and Y axis. After you have scaled, you may check to see if the dimension is perfect, satisfactory, and to scale as required. However, here I have 451 instead of 450. While this is a negligible discrepancy, you may choose to adjust the value of the approximation of the scale factor to get a more precise value for the scaled dimensions. Now, the next thing to do is to create a face for the partition walls on our 2D plan. This is a necessary step as it ensures that our walls are geometrically solid. After we extrude the edges more so, it is easier to select and extrude faces. We can use numpad 7 to visualize the 2D floor plan, and as you can see, it is exactly as we have it in our AutoCAD workspace. In essence, what we have in our AutoCAD has been successfully represented and to scale considering the metric system. Now we can go on to develop the 2D plan into a 3D model, and in order to do that, all we need to do is to select all faces and extrude towards the Z-axis by 3000, which is commonly the wall height from the ground floor slab to the roof beam. Now, in order to model the lintel level and window space, you can create loop cuts as shown. We can move the top edge to model our lintel level, which will also be our door height, and use the bottom edge for the window base level. And by doing so, we can have our lintel height as 2100 mm and the base of the window space to the ground floor slab as 900 mm. Then you may go on to work on the 3D model based on the specifications of the architectural 2D or as you see fit. This is it for our tutorial for today on how to import your 2D drawings from AutoCAD into Blender for 3D modeling. It is however important to note that the methods discussed in this tutorial aren't exclusive to images generated from AutoCAD, but also applicable to other 2D images as long as the image file format is supported by Blender. We hope that you were able to learn a thing or two from this video tutorial that can help you in your personal projects. Don't forget to subscribe to our channel for more video tutorials like this and turn on your notification bell to be the first to see our latest video tutorials. Thanks for watching and bye for now.